It's Labor Day, so you don't have to come to class. And then he said that we will have the exercise lab on September 6th, Wednesday. So as I announced, you need to bring your own laptop. This is do not miss this class to activate the Google Cloud account. So please bring your own laptop and think about your battery power, the fully charged. So I'm thinking to prepare the extra power outlet, but I do not know yet. So please bring your the laptop with the full charging. And the project, the phase 1 is due on the next week. I'm going to a little bit explain. The phase 1 does not require any database knowledge. It's just to define the functionality of the event system and title. So it's not the group project. You don't have to find the form of group. It's an individual project, so you can just imagine and make the functionality of your project. So I will explain a little bit more. Okay, so last class we talked about the data. So what is the data? In this class, the data is
organized information.
It's information. What kind of information?
Organized information.
Organized information or meaningful information. Something important information that we are going to manage. That's the data. So throughout the semester, whenever as I said, it's a little bit controversial between the data and information. Somebody said the information is to process the data. Yes, that's true. So then that information can be considered as the output of the data analytics. However, in this class, when we are talking about the information and data, information is general information. It's everywhere, but it's not organized. Okay? I support that idea. Think about Googling. Google is it's called the information retriever. We are not saying that Google is a database system. They use the database system behind, but overall Googling system is called the information retriever. Okay? Retriever is different from the database query. You will learn throughout the semester what's the difference. Okay, so that is the data. Then database
is software. Is a collection of
it's a collection of
data.
data. So when we had the full of the data, that's called the database. But at the time, so it's a collection, not just collect, keep, then put inside the bin, huge bin. No, it should be always organized. Data using the data structure. If we have the rule or concept, set of concept, so we follow that concept. So when you collect the data, you need to follow this way, this way, this way, which is called what? Model. Okay? It's a general software model. You need to follow the rule when you are managing the software. So in the software engineering. Database is the same thing. So whenever you talk about the model is a rule and concept and policy that you need to follow. So depending on the model, there are different types of model, like the network model, object-oriented model, and so on. Among them, we are going to use relational model. So you don't have to worry about what is a relation right now. We will learn what is a relational model. So among them, we are going to talk about the relational model. We will use it. Then, this is a conceptual level, like the data structure. So we need to utilize, I try to use this model, relational model, or network model, whatever. How can we use such a model, database model? How can we implement? Using always software. Okay? So, there's a software that implemented this idea, that is the DBMS, Database Management System. So, especially if you follow the specific, the database model, it's the RDBMS, Relational Database Management System. If you have the DBMS that use the object-oriented concept, OODBMS. Or if you have the hierarchical database model, it's a HDBMS, like that. In this class, we will use relational database management system For example, what's the example of the RDBMS? Most popular one is Oracle database, Sybase, SQL Server, a lot. Maybe 2,000, 3,000, 10,000. There are a lot. There is a lot of it. Then among them, in this class, we are going to use MySQL database. Good news, they are using the same concept. So 90% standardized. No matter what DBMS you use, it's the same syntax, same concept. Values, there are differences. The 10 to 20% are different. Oracle, not exactly same as MySQL. Okay? So slightly different. It's not very complicated. You can, if you know one of these, how to use it, you can easily catch it. So, however, you should be able to differentiate what is the database, what is the DBMS. But sometimes we use it interchangeably. So I know the database. I know Oracle is the data. Actually, Oracle is the RDBMS software. Then you are going to implement your own database using software. That's what we are going to do in this class. Yes, question?
You mentioned what I...
Oh, okay. So this is what we discussed the last time. Little bit more detail about the modeling. So this is a kind of outline data structure. Then we need the contents. We need to do something. That's your job in your project. Okay? So we have information. Information is everywhere. Our goal of design, database design, is build a database system in the computer. Oh, one more thing. So somebody after finish this class or after you graduate, you believe database is important. So all company or any computer system, they use the database system. Then what is the really database system and the database, the DBMS, database management system? It's nothing but software, like your Excel, like the Microsoft, or like the browser. It's a software running on operating system. Without operating system, you cannot. If you already know about the operating system, also the operating system is in between hardware and the user. Okay? Then you try to utilize or maximize or optimize the limited computer resource. Okay? And for better performance. Database is doing the similar job. However, still it's running on top of operating system, which means you'd better know the first operating system, okay, and network and other computer stuff. Then on top of that, you are able to manage and optimize and fully utilize a database system. That's what I suggest. In other words, I have been asked a lot. I'd like to be the database administrator. I know the payroll is very high, so comparing to other developer, administrator usually high. Then how can I be a database administrator? How can I be ready for that? At that time, do I need to take the certified exam, or do I need to read the textbook for the database? No. I usually suggest to study other core subject of computer science, network, and other data structure and algorithm. And even operating system also important, because the database is an application program running on based on this one. Okay. However, nowadays it's getting more important. Then, if you have such a fundamental of the computer science, then it will be much easier and stronger to understand data, database system, and then further data analysis to process such a data. Then go back to this one. This is a designing goal. From information, we need to build a database system. It cannot be done at once. You did. In your programming classes, you insert a SQL server, then create it's very easy. Click, 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 and customer. And click, 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 and item. Click, click, transaction. Then the SQL, if you do not know what is a SQL, don't worry. But the SQL looks like a simple select list of attribute from table name. We are a little bit conditioned, then that's it. I know the database. Then I don't have to take this class. You should, because it's anyway core course. Then I know you are geniuses, so you know that you can use it. That is just less than 1% of the database, okay? What if? So my experience, this is my real, the experience when I joined the first company, it was bank. So at the time, they are doing huge project, which is called the downsizing from the mainframe to the computer science at the client and server environment. So at that time, they changed the database from hierarchical database to the relational database. Then, when I get into the project manager, the database administrator, the supervisor, his room is not that big, smaller than my current office, but all three sides of his room is covered by the ER diagram that we are going to learn the next class, the ER diagram. ER diagram is the conceptual level of the database. Then he has, that database system has more than 2,000 tables. Then how can you design the more than 2,000 tables at once? It's impossible. So in this class, we pretend, practice, train the very simple database. Even the project, maybe 10 to 20. Some of the students create the 30. It's still not huge, but we better know such a process in pretending, mimic the real project. So first step is we need to organize information. So for example, if we build a university database or this classroom database, we need to know who you are, then we can. If I can manage individually everyone, it's a better teacher to know the individual situation. But I'm not that smart and cannot remember all of things, and I'm not very kind. Instead, for me, student is name, ID, and score.
Yeah.
That's it. I don't care the preference, whether you like the coffee or the sports, it doesn't matter. That's the information about the student. If I know individually your preference and I'm the guy who wake up early, so I don't care. What I need is a better score. The name, ID, and the GPA or score only. Then that is the organizing, okay, to manage the very large data. So then, for example, a lot of information about the student, but the organizing, my data structure, the definition of the student is name, ID, and the score. Okay, and there is a TA. TA is name, ID, and major, and other information. Also, TA assists the student, something like that. But the janitor, there's no relationship with the student. Like we conceptually, high level, organize such information as we define the data and database. It's a collection also meaningful and important information. This is called the conceptual model. There are different ways of the conceptual modeling, but in this class we are going to use the ER model, entity. This is called entity, this is called the relationship. Entity relationship modeling, ER modeling in this class. But this is generally used most of, not only database, in the software engineering, it's also used a lot. So UML is very similar as this kind of the ER modeling. It's slightly different, but very similar. Until this point, do you need computer programming? Do you need the computer architecture? Do you need the knowledge of the database? No. Only what you need is domain knowledge. Whether you know about the student, whether you know about the requirement. For example, if you have your customer who has to build a database design, you need to ask your customer, what do you want? Do you want to build this one? Do you want to manage this? Do you want to keep this information? And how they are related? At that time, there is no need for the computer science knowledge, computer science skill. Only domain knowledge and whether you understand. Especially in real life project, we need money flow, money related. Most of the company, they build a database for what? For fun? No, make the money. So money flow. That is the reason still such a conceptual design or ER modeling is performed by not computer science. Instead, business or CPA account, because they know how company is organized, or HR manager. So domain knowledge is more important. So that doesn't mean you can give up. If you know this one, eventually we will be this. So domain knowledge plus computer science fundamental will be more powerful. Nowadays, it's much more important. Why? We have more things to do after we build the design, like the data analysis, or the prediction, or the data mining, or the machine learning, such as stuff. It requires computer science knowledge. Then at the time, if we know the domain knowledge plus computer data structure, it will be efficient and more powerful. So do not ignore it. So for this step, you can start the phase one. Phase one is like the collecting the meaningful information for UV. So you are pretending you are the developer or designer as well as customer who are asking to. So you can imagine, think about what kind of event. You can limit or you can make the general for the event, the management system, and also what kind of functionality. So I can reserve or book a room, or I can create an event. Under the event, there are booking system, payment system. So you need to think about such a detailed requirement. So we don't need any computer. Don't worry about it. So Professor Lee does not cover anything by the September 8th, but now you can start. So because of this reason. So this is a conceptual modeling. Then the next step is, however, even though we organize such a data, like the ER modeling, whatever, so we will learn details about it next week, but it's still far from the database. Anyway, our goal is to build a database system using DBMS, but it's not enough. So we need to do that. This is a conceptual model. Okay? Sometimes it's called the data model. Then the next step is getting close to the database. So that is called the database model. By following one of these modeling techniques. Okay, one of these. So for example, we select a relational model. By following in terms of relational model, you don't have to worry about right now. In terms of a relational model, it has a relation. And each one has the attribute. And there's a primary key, and the foreign key, and constraint, and data type. Then using this information, we can change to the relational model, relational database model. Okay, this is the higher level, but it's a little bit lower level. Okay, still conceptual level, but it's not higher than this one. It's getting close to this by following one of these models. In our case, we will use a relational model. We don't know yet what is a relational model. There are certain rules and policy and concept, so we will apply such a thing. This is very straightforward. It's easy. There's nothing special thing. Just by following the rule. Step 1, step 2, step 3, step 4, and step 8, you can convert this one to the relational model. The next thing is, we need to decide which DBMS we use. This time we need specific database, the knowledge, like how to use the SQL, how to create the database. At that time we need something syntax of the SQL. Using the SQL, so we can create the data. At that time, we need to specify the storage and what type of, depending on the DBMS. At that time, we use the relational database management system. For example, MySQL. The MySQL support data type, integer, decimal, and we need to decide such a thing that's called the physical database model. Physically, we are going to create the database. Okay. Then, finally, we can build a database. Then what is the purpose of building a database? We'd like to use such a data, right? So how can we use? Sometimes you can use language provided by the database, especially relational database provide structured query language, database language. Don't be confused. SQL is sometimes called SQL, sometimes SQL, it doesn't matter. It's a structured query language. This language is only for relational model. You cannot use the SQL for other database. You cannot use the SQL for Excel. You cannot use it for any other. Only relational database. Also vice versa. Relational database, the only way to access the relational database is through SQL. Sometimes I can access the data, Oracle database, or the SQL Server database without SQL. Yes, it's a component, or LINQ, or component-based programming. It hides, abstract the SQL inside. Then you just give the table name, attribute name, and automatically, not automatically, it's already code inside. So you may not realize whether there is a database query or not. So that's the one of the reasons, because SQL itself is additional language, database language, in addition to the program language, Java, Python. So it's more complicated. So people don't want to mix the languages, so this is hidden. Yeah, but still there are languages inside. So plus we are going to use a program language. In this class we limit for your better experience on the MySQL on the Google, the cloud platform. We will use only the program languages supported by the GCP. So you can use a Java. Also you can, but problem is C# and the .NET. ASP.NET is not supported in the Google Cloud. So that's good for you for better experience. This is a good time to learn such the new computing environment. Okay, so you can right now start your page one. I'd like to discuss a little bit more about the conceptual design and the physical design and so on. 20, maybe 30 years ago, the people, I explained about the computing environment from centralized server, downsizing, and the client server, and the 3-tier, like the middleware application server. Client is a 3-tier, and nowadays is the cloud computing environment. So, as you can see, the getting popular database server is getting popular. Most of the system has such a database. So, the researcher and the industry, they get together, then they try to standardize the database, the architecture. So, they define the 3 schema architecture. First, conceptual schema means, schema is kind of description. Description, when we are saying the database schema, it's like the student and the teacher and the assistant. It's a schema, description of the database. So conceptual schema means so this conceptual schema. It's before implementing your database using DBMs. Before, it's a database model, database design part. So this is a conceptual schema. Then, if you create the database inside the DBMS, using DBMS, it will be stored somewhere in your file or operating system, the file system, right? So that is the internal schema. So internal schema, who is in charge of the internal schema? DBMS. Whenever using the SQL, if you create something storage for the student, it will be created. At that time, you can use a conceptual schema. That is what you design. Using conceptual schema, then you can create inside. You don't know how it is stored. You don't have to worry about. Okay? So where this is file, the student, my data is in this file, or this file, this location, you don't have to worry about. DBMS is in charge of such an internal schema. They separate. Why? Why they separate the conceptual schema, internal schema? Why they separate? It's abstraction. Yeah. Hiding the details of the storage. It's very complicated. So instead, I can give just, I need a storage for student. Then will be created inside. So there's an internal schema. They separate. It's a program and data, it's a data independence. Schema and data, physical data is independent from the student. For example, sometimes storage is full. So you need to add a new storage. Then copy half of them to here. Do I need to change the student information? No, we don't change. However, if we do not separate this one, we need to delete, remove the student and recreate again. So it's painful and your system should be stopped. Instead, if we separate such a conceptual schema, internal schema, it can be done inside, but in this level, for user level, we don't have to change anything. Name, ID, and GPA will not be changed. That's it. That is the conceptual schema and internal schema. Then, plus, there's another schema. This is the external. External schema means, for example, student, we need name, ID, GPA. HR department, the payroll department wants this information. But payroll department doesn't need the GPA. Okay? So, however, we have only one schema, one table, one student information. Do I need to give all the information to the payroll? So it's not secure. Instead, we can create different view. We have only physically one the storage, okay, for student. But some user can see only half of this. Instead of creating new database, or instead of giving all the permission, just see half of them. So from different user, like the payroll can see the student as name, ID only. This is the different view, instead of creating new one. So it's for what? Benefit? Secure. Also, we don't have to create the duplicate data. Instead, we have only one data. It's easy to maintain. In other words, it's a consistent. It's a consistency. Consistency is very important. Later, I will mention many times later. Consistent. So this is an external, conceptual internal schema. So this is called the three schema architecture. Most of the current database system follow is three schema architecture. This is actually NC standard, American Nation, the blah 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 standard. I cannot remember, but it's the NC standard. So this is a three schema architecture. What we are going to focus on is these two, especially conceptual schema. Instead, internal schema is will be taken care by each vendor. Oracle will have the different. So this is not standardized. Each DBMS has the different internal schema. You don't have to worry about too much, unless you are really serious developer. Sometimes you need to, you better know, but most of the time you don't need. However, we will focus on the conceptual schema plus external view for your design and the implementation of the database. Then, once we have this kind of the database, we have the different types of user. It's not very important, but in the textbook you will see different types of user. I already mentioned about something database administrator, DBA, and a user, just the normal user. There are different types, but first, the database administrator is the kind of admin, network administrator, Unix administrator. It can actually manage the entire system. Okay, it's like a root the user in operating system or administrator user in the Windows system. So database administrator mostly manage your database system. The other user is the owner of the schema, owner of your context. Database administrator is not the owner, even though the DBA has the permission, but it's not owner. Owner is the owner of your database of each user. Each user also has a different type, like the end user. End user is only view only, slot only. Sometimes limited update the data. End user. Nowadays, there's another type of the user. It's the analyst. Using this information, we process go better, like the data analytics or the statistics by applying the statistics. We are not going to discuss this part more in this class. But if you are taking the data mining course or big data, so or NoSQL data, so we will talk about this more later. Okay, any questions so far? So in this semester, so first I think the 6%. Like the first 9 weeks, 9 or 10 weeks, we will learn this, including programming part. That is also same process as your project. Okay. Then plus, one more thing is DBMS. What is the DBMS? DBMS is a software. Software for what? Following relational model. Plus, go back to the fundamental reason of using data. Why do we need to use a database? The Professor Lee and in this class we talk about a lot data, database, the DBMS. Then why do we need to use the database?
Before it, repetition.
Repetition?
Yeah, repetition.
Repetition of what? Function or?
Yeah, controlling reduce.
Reduce?
Controlling the repetition.
Controlling repetition. In other words, am I correct? So I want to make sure. So when we have the duplicate data,
yeah.
So we want to reduce the duplicate data. That's very important. For example, so like I move the new house or apartment. I need to inform to state government or the federal government and the UB everywhere. It's really painful. Instead, if we have the one, so I'm the only one, okay? Then my address is only one. So if we have the